Hi everyone, you're welcome to this week's um classes. Today we are going to be looking at the past GCSE question and answers on physics. We are going to be looking at the topic energy changes in a system. If you have been going on with us, we are using the PMT flashcard where a lot of past questions are there. So we'll be dealing with some questions and how to tackle them. So you go post with us and see how we are going to move on with everything as it is. Um, so what is the equation for kinetic energy? Give SI unit for all quantities involved. This can be another question, the way the question come, and this is how you answer it. Now, uh, the uh, the the equation for kinetic energy is half mv squared. Half mv squared. Half mv squared. M stands for mass and then v stands for velocity square. Now, which is half mass times velocity square. And you all know that the unit of mass is kilogram and the unit of velocity is meter per second square. So let's try out the question. If we are given to calculate a certain um, um, energy, and then we are asked to look at how it works. This is how we are going to tackle it. We're going to be using this equation. So if you're asked to calculate the kinetic energy, if a mass of 50 kilogram is contained in 5 cm cube or meter cube of meter per second, that's the velocity of a given um, quantity. How do you solve it? And the SI unit is joules, mass, kilogram, velocity. Now, energy is in joule. Now, the mass is in kilogram and velocity is in meter per second. So, I'm going to take us to the screen where we're going to solve that question, how to calculate the kinetic energy of a given let's assume we are asked to calculate the kinetic energy. Kinetic energy is given by half mv squared. So if mass, according to the question, is 50 kg, and then our velocity is 5 meters per second. So kinetic energy will now be half of 50, that is the mass, times what? 5 square. So this gives us what? Half of 50 is what? 25. So we have 25 times 5 square is also 25. So when we solve it out, it's going to give us some 25. Let's solve it out here. 25 times 25. 5 times 5 is 25. Right, 5 carry 2. 5 times 2 is 10. And then 2 times 5 is 10. 0. 2 times this is no. This is 10 plus 2 is 12. Okay. 5 times 2 is 10, right? 0 carry 1. 2 times 2 is 4 plus 1, 5. So we are going to have 5, 2, 6. So our answer is 625 joules. Because the heat of this is joules. So this is how we solve it. This is how we calculate the kinetic energy of a given mass. So I'm going to return us back to our share screen and we'll go back to the question. We're going to go back to the question that we're solving. So that is it. So we're told that the kinetic energy of a given How to calculate is half mv square, and we saw it there on the board. So we're going to proceed now. And the unit is joule. Mass kilogram times meter per second gives you joule. So that's it. So what is the equation for elastic potential energy? Give SI unit for all quantities involved. Now, the equation for elastic potential energy is half k x squared. And then half is here. The k stands for spring constant. And then the x stands for extension. Spring constant times extension. We are talking about elastic potential energy. So when anything is elastic, then there has to be an extension until it reaches its elastic limit. So we are still talking about energy here. So energy is measured in joule. The spring constant is in Newton per meter, and the extension is usually in meters because it is a distance. So we're going to take an example. If the spring constant is 20, and then our extension is by 5 meters, how do we calculate the kinetic energy? I'm going to take us back to the screen, and then we're going to see how to solve this out. So come with me as we do that. So I'm going to clean the previous one, and then I'm going to deposit this new one here so that we can see how we can tackle it, solve it out. So when you are tackling any GCSE question, try as much as possible to understand the terms, and everything will be given to you. Physics is just practical. Everything will be given to you. Once the formula is given, there will be one unknown for you to solve it out. So if our spring constant is given as probably 20 Newton meter, and then our extension small k is given by 5. So we are told that energy is given by half of what spring constant times extension, which gives us what half of what the spring constant is 20 times the extension is 5. So we are still going to half of 20 is 10, 5 squared, so k squared, sorry. So times 5 squared is still 25. So when you multiply that, you're going to be having 250 joule. 250 joule. So the kinetic energy when the spring constant is given and every other thing is given, that is how you solve it out. So I'm going to return us back to our screen. So the equation for the elastic potential energy is given by k times x squared, where x is the extension and then k stands for the spring constant, and the unit is still in joule because that is how it was given. So what is the equation for gravity potential energy? Give the SI unit for all involved. Gravity potential energy is given by mass times gravitational field strength times the height, mgh. So m stands for the mass, g stands for the gravitational field strength, and then h stands for the height. Now the energy is measured in joule, and then the mass is measured in kilogram, gravitational field strength is measured in Newton per kilogram, and then the height is measured in meters. So if you are going to calculate this, let's give ourselves an example. It's given by mgh, gravitational potential energy. Now we are talking about kinetic energy. Now we're going to be looking at potential energies and how to solve it out. So I'm going to take us back to our screen, and then we'll clean this out and see how we can solve the potential energy of itself and see how it is. So we are given by that, and we're going to try it out and see how it works. So we are told that the potential energy PE is given by mgh. So let's take our data. For instance, if M, the mass is maybe 10 kilogram, and then the field gravity. Field gravity is usually mm, acceleration due to gravity is usually 10 or 9.8 meter per second square, and then the height, let's say is 5. So we want to calculate the potential energy. Potential energy will be given by M, which is 10 times 10 times 5. 10 times 10 is 100. 100 times 5 is what? 500. So we want to have 500 joule. Whether potential or kinetic. Energy, whether potential or kinetic, is always measured in joule. So that is how we're able to give that, and then we're able to solve it out. So I'm going to turn us back to the question where we're going to get what we want. So this is the equation of gravity and potential energy is given by mgh, where m stands for the mass, g stands for the gravitational field strength, and then h stands for the height. Energy is measured in joule, and then mass is measured in kilogram, and the gravitational field strength is measured in